Okay, so till now you are able to find the derivative of functions like y equals x raised to power 5, okay, or maybe y equals x raised to power 7, and so on and so forth, right? Functions like these using the power rule. Okay, so now let us learn something new. For example, if I ask you the derivative of y equals x raised to power 5 plus x raised to power 2, okay, so how do you find the derivative of such a thing? So I won't go into the exact details of such a thing, but what actually happens is, okay, by when we differentiate such a function, we say differentiate both the sides, right? So we simply get dy by dx this side, and here how do we write this d? So a small change in the whole function, right? We just write this inside the bracket. So I'm just trying to tell you the whole procedure by which we go. Okay, so this is the whole thing, right? This is the whole y, dy by dx, and y here is the whole thing. So dy by dx, or dx is to power 5 plus x, the whole thing, by dx. Now we don't know any formula that, so we don't know the derivative of this whole thing, but what we can do here is sort of distribute. Okay, this is not actually distributing, but we can call it distribution. Okay, so we can distribute our derivative operator on both the terms here. So whenever you've got addition or subtraction, two terms, you can simply find the derivative of both the things. So in short, the derivative of this whole thing is the derivative of this plus the derivative of this. So I can distribute it, so to speak, and find the derivative of dx raised to power 5 by dx. So this is a step, okay, and I'm just separating the two steps, okay, plus dx square by dx and dy by dx, right? And now as usual you can find the derivative of x raised to power 5 and find the derivative of x raised to power 2, which is simply 5x raised to power 4 here, plus 2x, which is nothing. Yeah, so that is your final answer. Y dy by dx equals this. So this is your final answer. So that is just how you calculate it. One more thing that you should know is that, just a second. Yeah, so if you've got a coefficient, it just stays there. Okay, for example, if I ask you find the derivative of this, so if you're finding the derivative of such a thing, you simply write dy by dx equals, so the 5 is the coefficient here, right? You just leave it, it remains as it is, and then you find the derivative of, so this into, now differentiate this term, right? And now you simply use your power rule, equals 5 times 2x, which is 10x. And the logic behind this thing is, so here I've got my derivative as 10x, sorry. So now the logic behind this whole operation, I've got 10x right here. So wait, I'll just write it again. So y prime equals 10x, and if I had got this, okay, y prime in this case would have been simply 2x. Now just to get the intuition behind this whole thing, so if I draw this y equals x square, and you need to be very familiar with graphs for to know the logic behind this thing, but I'll just give you the brief overview of this. If I have the graph of x square here, this, and if I multiply this, so if I just add a 5 there, if I multiply the whole term with 5, what am I actually doing to the graph? I'm actually making the whole graph steeper by a factor of 5. So my graph simply becomes this. That gets more steep. Okay, earlier the graph was less steep, now it got more steep. So this is 5x square. So the whole graph got 5 times steeper, which means, and steepness is slope. Slope is derivative. So this derivative should also increase by 5 times, and that is clear here. It was earlier 2x. In this case, when I multiply this by 5, my derivative also increases by 5, and my graph gets 5 times steeper, and so does my derivative increase by a factor of 5. So that is how you can calculate derivatives. And I think, yeah, that's it for this video. Let's meet in another video. Okay, bye.